Bismillahirrahmanirrahim. In this video, we are going to look at certain examples and see how we can normalize the database to avoid all the anomalies that we discussed in the previous video. The anomalies being mostly the insert, delete and update anomalies. So let's start with the first example. So I took this first example from this website, and you can see here we have the full name, the physical address, the movies rented by the person, and the salutation, how you are going to address that person. So either a Mr., a Mrs. or a Miss. And you can see that, if you look at it, what's wrong with this? What's wrong with this database? And if you look at it closely, you can see first thing is that one person can rent more than one movies. So for instance, Janet Jones have rented Pirates of the Caribbean and Clash of the Titans, and simply this person has also rented two and this person just one. So that's the first issue you have. You can see here with the comma that the person has rented more than one movies. And the second problem is that it's not really a problem, but it's something that you have to take account of. It's that multiple customers can have the same name. So just having the full name is not enough to be a unique identifier. So the primary key cannot be the name because there can be a repetition. So to deal with this kind of data, there are two things you can do. The first one is very obvious. Since it is a multi-valued attribute, I have to somehow decompose it so that it does not become a multi-valued. I need to have a unique value for each cell in my table. And the second part is a bit tricky because there are two things I can do. Firstly, I can combine these two attributes. So the full name along with the physical address can form a combined primary key, or I can introduce what is known as the surrogate key. It means just maybe a serial number or membership ID or something like that, which we'll see what's the best way of doing that. So let's for the time being assume that the full name and the physical address together make up the primary key, and try to solve for this. So to do that, we need to, so is it in first normal form, the original data, is this in first normal form? And the answer is no, simply because there are multi-valued attributes. So how to make it into 1NF? So each table cell should contain a single value, and so we have split that, and each record needs to be unique. So to make it unique, what I can do is I can have all these three values to be a primary key. So if I do that, then I will be unique, and it will have, all the cells will have a simple value, a singular value. So in that case, so full name, physical address and movie rented together will form the primary key, and there is no repetition here, so therefore it's in the first normal form. So is it also in the second normal form? And to look whether this is in the second normal form, what we can do is, so is there any partial dependency? So to have a partial dependency, what I can see is that if I make a composite key of these two only, then what happens is that names are common, hence you need name as well as address to uniquely identify a record. So is it in the second normal form? To be in the second normal form, you need to have to be in the first normal form and have no partial dependency, or have a single primary key column. So since it does not have a single primary key column, what I can do is either I can make the three of them together as a primary key, then maybe I can have a unique value. But the problem still remains that if the same person rents the same movie again, then I will have a problem. So that's not perhaps a good idea. So what I can do is I can introduce a surrogate key. So here I introduce the membership number, and the membership number is unique, and so with that I have the full name, the address, and the salutation. So membership ID 1, 2, and 3, and whenever that person rents a movie, I just write that ID number 1 has rented this movie, and so this is unique. So in the second table here, since membership can be repeated, so it's going to be membership ID and movie rented. So they're going to both form the primary key. And since there is nothing else, so there is no question of having a partial dependency or a transitive dependency. That can only happen when you have other non-key attributes. So if you do this, so at least this one, this table here, at least this one is in 3NF, because there can be no violation. Now the question arises about this: is it in 2NF? Is it in 3NF? And to answer that, we look at the nature of the term. So is it in 2NF? To be in 2NF, it has to be in 1NF and have no partial dependency. So if I look at this, apparently name and salutation can all depend on the membership, physical address depend on the membership, it's fine. But there's a problem here. The problem is that suppose this person, for instance, changes her name, maybe she gets married, and then from Janet Jones, from Miss Janet Jones, she become Mrs. Janet Jones or something like that. So you can see that the membership ID will not change. The person is the same, but either they have changed the name, so the salutation will change. So it means that the salutation is now depending on the full name rather than the membership ID. So here we see that it is in there's an issue with this. So this depends on this, and then this depends on this. There is no partial dependency issue because there was only one primary key. So this was the primary key. If we have this as the primary key, so if we say that there is no partial dependency, or it is a single column primary key. So if it's a single column primary key, you cannot have partial dependency, because partial dependency means that your primary key composed of two attributes, and there is a non-key attribute here that only depends on part of the primary key and not the complete primary key. So this would have been a partial dependency if I have B, but B depends on the entire key, so this is okay and this is not okay. However, if I have a simple single column primary key, for instance this one, so I cannot have an issue with partial dependency. So it's going to be in automatically without doing anything. When I resolved for the first normal form, it automatically was also in the second normal form. So we have to look at and see whether it's a third normal form, and as I was saying that for the third normal form, this is an example of a transitive dependency. So the salutation depends on the person and the person depends on the membership. So here we have a problem with the transitive dependency. So in transitive dependency, we are not constrained with the primary key. It simply means one non-key attribute is dependent on another non-key attribute which is dependent on the primary key. So the middle attribute does not have to be part of the primary key. So just because the primary key was a simple or a single value, it does not mean that you cannot have a transitive dependency. You can still have transitive dependency as long as you have non-key attributes, more than one. So in that case, you can have a transitive dependency. So this was the data this was the tables in the second normal. Basically, it was in the first normal form, and automatically it happened to be in the second normal form as well. Now if we look for this, we can convert it into the third normal form. And as we saw in the last video, how do you convert something into the third normal form? You take the attribute that is dependent, the attribute on which it depends, and create a new table, whereas the attribute on which it depends is going to stay in this table as well as the new table. So what we can do here is the full name is here, the full name is also the salutation ID and the salutation are here, and we can have the memberships here and the ID over here. So the salutation and the full name were dependent, and so we have separated it into different tables. And now the question arises, why didn't I use full name and salutation? And the reason was full name cannot be a primary key because you have a repetition. So instead, because I introduced a surrogate key, if I did not have this surrogate key, then full name would have been here and this would have formed the composite key. But since I did introduce the surrogate key, a surrogate key means an artificial key. It was not, if you look at the original data set, there was no membership ID. So membership ID is a surrogate key. It is an artificial key that we have introduced, which was not part of the original data. So for that reason, I'm not saying that the full name and salutations should form the new table. Instead, the salutation ID and salutation is forming the new table, and the salutation ID is being used here. So if a person changes the salutation, then all I need to do is just change the salutation ID, and that's it. I don't have to go and repeat things again and again. So with that, is it in the third normal form? Yes, this this set of tables are now in the third normal form. So let's look at a second example. So this was an easy example. There were not a lot of attributes and there were very few problems, except that we introduced a surrogate primary key. Other than that, there was nothing tricky here. It was a straightforward case of first normal form. You didn't have to do anything for the second normal form. It was automatically in the second normal form, and we used this to convert it into the third normal form. So let's look at another example. This is a slightly more complicated example. So here we have a patient, a surgeon, a surgery date, the name of the patient, the name of the surgeon, the address of the patient, what surgery was performed, what was the drug prescribed, and whether that drug has a side effect or not. So this is the original data. So patient number 1111 who had a surgery. In fact, he had two surgeries. The first one was performed by surgeon ID 145 on the 1st of January 1995, and well, the patient is the same because the same patient, and the address is the same, and surgeon number 145 was named Beth Little, and the surgery performed was for gallstone removal. For that, the drug prescribed was penicillin, and the side effect of this penicillin is that it can cause a rash. The same patient underwent a second surgery, this time by surgeon ID 311, who is Michael Diamond. The surgery was performed on June the 12th, 1995. Patient name is the same, address is the same. Of course, the name of the surgeon is different now. And the surgery was performed for kidney stone removal. There was no drug prescribed, and since there was no drug prescribed, there is not going to be any side effect. So you have this data for one patient. As we can see here, there are different dates, there are different surgeons, there are different surgeries, different medicine, and different side effects. So definitely this is not in the first normal form. This is an unnormalized form. So to convert this into the first normal form, what I need to do is I need to remove all these multiple values inside a cell, and to do that I have this table now. So I have just repeated it. So patient number 1111, the first surgery is in the first row and the second surgery is in the second row. So ideally I would like to have this kind of dependency, because a patient can have multiple surgeries by multiple surgeons on multiple dates. So therefore the patient number, the surgeon number and the surgery date will uniquely identify each row in this table. And ideally I would like to have something like this. So this the combination of these three attributes. So So the combination of these three attributes, so the patient number, the surgeon number and the surgery date, this form the composite key, and this is shown here as the composite key. And ideally I would like all my other attributes to depend on the entirety of this. So is that the case? And let us look at the patient number. Does the patient number depend on the surgeon? No. Does it depend on the date? No. So this patient number is only dependent on the patient number. The patient name is dependent on the patient number. Patient address is also dependent on the patient number. The surgeon name is dependent on the surgeon number, and the surgery is that's dependent on the patient, the surgeon and the date. And the drug is also dependent on that, and the side effect is also. So basically patient number and patient address is only dependent on the patient ID, and the surgeon name is dependent on the surgeon number. So what are the problems? So we know that this is not in the second number form, so it's in the first number form. But let's look at what we said, that there are going to be insertion, deletion and updation anomalies. Let's look at that in detail. What is going to be the problem? So the anomalies in the storage using the first normal form is that for insertion, if a new patient has to undergo surgery but has not undergone it yet, hence there is going to be no surgeon because the surgery has not been performed. Since surgeon number is part of the primary key, it means that we cannot enter the record of a new patient until and unless that patient goes through a surgery. So we cannot do it before the surgery. So that's an insertion problem. And the same thing goes for the surgeon. If you have a new surgeon which have not operated yet, that means because the patient number is also part of the key and the surgery date is part of the key, it means that a new surgeon cannot be entered in the database. What about update? If a person comes in for a new procedure, it's the same person but he or she have changed their address, then we have to search the entire database and go and change all the addresses of that same patient. So these are the insertion and the updation anomalies. For deletion, there are two types of anomalies. The first one is that deleting a patient record may also delete information about the surgeon. And the second thing is that when there are functional dependencies such as a side effect and drug, changing one item eliminates the other information. So we'll discuss this the side effect of the drug later, because that's another functional dependency. So these are the type of anomalies that we will encounter in the first number form, and therefore to do that we make a dependency diagram, and we see that the patient name and the patient address is dependent on the patient number, and the surgeon name is dependent on the surgeon number. And as I said, this also is a problem, but this is a transitive dependency problem because drug admin is not part of the primary key. So a partial dependency only happens when something is dependent on part of the primary key. So since this is not part of the primary key, so this is not a partial dependency issue. It may be a transitive dependency issue, but it's not a partial dependency issue. So to do that, what we can do is we can separate these two. So patient number, patient name, and patient address can move to a separate table. Surgeon number and surgeon name can move to a separate table, and of course the patient number and surgeon number are going to stay here because they form part of the primary key. So to make it into a second normal form, we do is we have the patient number, the patient name, and the patient address separated, and then the surgeon number and the surgeon name separated, and the remaining data here is now does not have any partial dependency. So the surgery is dependent on the entirety of this, and the drug is dependent on the entirety of this. The side effect is also dependent, even though it's dependent on the drug, but since drug is not part of the primary key, so we don't have any issue with partial dependency. So now with these three tables, the first one, the second one, and the third one, with these three tables, we are sure that our data is in the second normal form. Is that good enough? Let's see. Now we can insert a new patient without surgery. Reason being, we have this table, so we can have the detail of a patient irrespective of whether that patient has undergone surgery or not. Now we can enter a surgeon who have not operated. That's also fine. Now there is a problem with deletion. If Charles Brown dies, the corresponding tuples from patient surgery table can be deleted without losing information. So this is also fine. So insertion is fine, deletion is fine. If John White comes in for a third time and has moved, we have only to change one address, and the reason being that John White lives here. So if he has moved, we are only going to update this part. So all these insertion deletions are fine. However, there's a new type of problem here. So what's the problem? For an insertion, you cannot enter the fact that a particular drug has a particular side effect, because that entry can only happen when the drug is prescribed to someone who has undergone a surgery. So without that, I cannot say that this drug has this side effect. So that's my insertion problem. And if a person that was diagnosed with something, underwent a surgery, was given a drug which had a side effect, if the detail of the surgery is deleted, then the information that this drug has this particular side effect will also be deleted. And the same goes for update. If I were to change the fact that one drug has a side effect, so I'm going to have to scan the entire database and look for all those surgeries where the drug has been prescribed, and then go and change all the corresponding entries. So I've solved this insertion, deletion, and updation problem, but I have new set of insertion, deletion, and update problems. So that's why 2NF is not enough. So what can we do? We have the first two tables. So patient number here, this is the primary key. The patient number is the primary key. So the patient name depends on the patient number, the patient address depends on the patient number. There is no transitive dependency, so address doesn't depend on the patient name, and there is no partial dependency because there is only one primary key attribute. So there cannot be an issue with a partial dependency. So this is automatically in 3NF. There is no issue here. This also has a single primary key, so automatically is in 2NF. There is only one non-key attribute, so the problem of a transitive dependency cannot occur, because that happens because one attribute here is dependent on the other, and that is dependent on the primary key. So this, since it's only one attribute, we cannot possibly have this scenario. So this is also in 3NF. So what remains to be seen is whether this table here conforms to the 3NF, and we saw that No, it does not, because this is what was causing all the insertion, deletion and updation anomalies, because there is transitive dependency. The side effect depends on the drug administered rather than the patient, the surgeon or the date. So to do that, we have split it into two, and the drug administered and the side effect now have a separate table, and the drug administrator is also part of this table. And because we don't have a surrogate key, therefore it is this attribute that will be replicated, and there is no question of the surrogate key as we saw in the last example. So now in this table we have the patient number, we have the surgeon number, and then we have the surgery date. This from the primary key. There are only two attributes, so surgery is dependent on all these, and drug administration is also dependent on all of them. So no question of partial dependency, no question of transitive dependency. In this case, again, since it's only going to be if I have the drug here as the primary key, then the side effect only depends here. It's only a single primary key, so there cannot be a partial dependency issue. There's only one non-key attribute, so there cannot be a transitive dependency issue. So this is also in 3NF, and this is also in 3NF, and we saw the first two tables are also in 3NF. So the anomalies that were removed were that we can now enter the fact that a particular drug has a particular side effect, and if somebody that was taking this drug is deleted from the database, the fact that the drug has a side effect still remains in the database. And if that side effect changes, I have to only make a single update and not throughout the entire database. So all the values here are now catered for, and this is the final result of the third normal form. So a single table has now been decomposed into 4 tables to make it compatible with the third normal form, and each of the 4 tables now conform to the third normal form. So we say that the entire schema now is in the third normal form. So up now we have dealt with the third normal form, and for most applications this is going to be satisfactory. When I say most application, it means most non-critical application. If you have a simple database for students, simple database for a library system, maybe a small store, we don't have a lot of attributes and very complex relationship between the tables, third normal form is 90% of the cases more than enough. So if we're making this database, I will stop here and then start converting these logical design into physical design. So start with the whether this is going to be a character or a variable character, and what type or what constraints I have over there, what's going to be the physical index, and how do I maintain the primary key and stuff like that with physical design. But that's it for the logical design for most of the databases. However, there are going to be some databases where even the third normal form will still leave certain anomalies, and that happens when you have a joint dependency or a multi-valued dependency. So this will become part of the next set of lectures about the higher order normal form, so the Boyce Codd normal form, the fourth normal form and the fifth normal form, along with their examples. So that will be for next week. This is it for this week. I hope with these examples the 3 normal forms are very clear, and now even if you were using the old method where we had the conceptual design and the logical design followed by just a translation from the ER diagram into the logical design, you can still now ensure by using the 3 normal forms that at least your database conforms to the third normal form. And in fact, if you didn't go through all that and you let all the attributes in one large table and you apply the rules of the first 3 normal forms, you will still arrive at this. In fact, that's exactly what we did here. We had everything in one table, and then we started splitting until we ended up with 4 tables. So if you have any questions, if there's something you don't understand about normalization or about any of these examples, you can ask me during the question answer session, or you can ask me in the YouTube comments, or you can ask me on MS Teams. So that's it for this week.